Okay, so what we're going to be doing first is from 3.1, ready, set, go, 13, 15, and 16. So what we're really just, what we're really doing first is we're just trying to, actually, here's the directions. It says, find the rate of change, write the recursive rule. If it's constant, then write in the constant value. If the rate of change is a function, then write the equation of the function that describes the rate of change, and then identify the type of function. So down here, these are the things that you want to do. So when you're doing this, my first piece of advice is to find out your differences, because that's going to tell you a bunch of stuff here. Number one, that is your rate of change. Number two, you can build your recursive rule off of your rate of change, which can also tell you what your type of function is, okay? So the first thing that I'm going to do is I'm just going to go in here and subtract. So that's 1, that's 2, that's 3, that's 4, and that's 5. Now already you should be thinking, oh, that's not a blank kind of function, right? Because these numbers change here, it's automatically not a what kind of function. Let me see. Yeah, it's not a linear type of function. How do you know that, Ms. Johnson? Well, if these were all the same, like over here, -5, -5, -5, -5, -5, your rate of change is -5, and your type of function is it's linear. Okay, because remember that whenever you're looking at a function and the first row of differences is constant, -5 all the way through, that implies that this right here is a linear function. But these numbers are not the same. So I'm going to take my second row of differences. So I just go here and I subtract. And I'm like, oh, look, they're all ones. Okay, because the second row of differences are all the same, and it's going to show up, I'm pretty sure, pretty soon. Because all of this second row is exactly the same, this implies, let's just write this here. Okay, because those are all the same here, this means that this type of function is what? Oh, it's not catching up to me. I don't know what to do here. Hold on a second. Okay, let's just pretend that there's a bunch of ones here. You know the differences. There are a bunch of ones. So yeah, this implies that this is quadratic. So I'm going to write that quick little note there. Because the second row, or whatever, second set of differences are the same, then it is quadratic. Then the function, I should say, the function is quadratic. Okay, so let's put this here. Write this in my font so you guys can all find it. I'll highlight it. Okay, so here it goes. So because my second set of differences is all the same, and so I'll take my little arrow and point at it there. Right? So because those are all the same, right, then that means that we get that it's quadratic. Okay, so let's just write that down here. This is quadratic. It's also asking, okay, well, what my rate of change is. Now your rate of change is this number here. They're looking for a function. So when they're looking for a function, they're asking, okay, well, if I plug in 1, what is this function? What is this function going to be? So can you imagine me creating another little table here, and then this 1 goes right here. It matches up with this one. This 2 matches up with this 2. And you're like, hey, Ms. Johnson, those numbers, they're exactly the same. Exactly. So our rate of change here is just n. Our rate of change here is n. Now, it was easy to pick off this rate because look, the numbers are 1, 2, 3, 4, 5. So it'd be a little bit different if the numbers were a little bit different. But you'll see as we find more rates of change, you'll understand how to find it. So here it was just 5 matches with 5, 4 matches with 4, 3 matches with 3, 2 matches with 2. So really it's just whatever the input value is, in this case, n. Okay, if you remember from before, this was our function. It's your recursive rule is always going to be f of n equals f of n minus 1 plus your rate of change. So you want me to write that down, Ms. Johnson? Yes, I want you to write exactly that down. So f of n is equal to f of n minus 1 plus your rate of change. Now, in this case, your rate of change is, in this case, it was -5. So we put a -5 there. That's your equation. So in this case, what am I going to put here? I'm going to put this n right here. Okay. And that's pretty much it. So your recursive rule is always going to be next equals previous plus your rate of change. In this case, it's n. Okay, does that make sense? Hopefully it does. So there goes that. I'm going to move on to the next one, right? Okay, so the next one, still going to do the exact same thing. I'm looking for my sets of differences. This is 3. This is 5. And notice now I'm putting my rate of change on the second, like closer to the second line, because that's where he belongs, right? And so this would be 7. And you're like, oh, Ms. Johnson, I see the pattern. Exactly. But it's not linear. I already know this guy's not linear, right? Because these numbers are all different. So I'm going to do that again. Second set of differences, again, lining it up more with the second row, not the first. So this is 2, 2, and 2. Oh, okay, Ms. Johnson, look, it's the second row. So because the second row is the same, what type of function is this? And someone says, oh, Ms. Johnson, it's quadratic. Exactly. So I'm just going to type this here so it's faster. Oops. Type here. There it goes. So yeah, it's quadratic, Ms. Johnson, because the second row is the same. My rate of change. Okay, now this one was a little bit different. This one, it was easy. 1, 1, 2, 2, 3, 3. Now they want you to find your rate of change. Now this one is a 2, and then it's 3. 3, and then it's 5. 4, and then it's 7. 5, and then it's 9. And you're like, Ms. Johnson, I can't really see this. So I want you to like pull this back to the day that you were finding the equation of a line using this. So imagine that you have these values, and I'll draw another little kind of table right here, just so that you can see these values. Oops, I didn't put it. I don't know where. Oh, there it is. It's right here. I couldn't find you. Okay, so I'm going to put in these numbers again. 1, 2, 3, 4, right? And here, I'm going to put the values that I get. Now, 1, I didn't get anything. 2, I got a 3. 3, I got a 5. 4, I got a 7. So 5 and 7, right? So if I was looking for the equation of this line, the very first thing that I would do is try to find the slope. And you're like, oh, Ms. Johnson, you would subtract again? Yeah, I'd subtract again, except for this comes from all the way over there. Same numbers, it's just a 2, right? So that implies that my slope is 2 because the change is here, right? Your slope is rise over run. So it's the change in 2 versus the change in x versus the change in y. So here my m is equal to 2 over 1. Right? So I'm just really filling out this equation, y equals mx plus b. I already found out what my m is. My m is 2, right? So my equation is going to be y equals x plus blank. Okay, so this is going to be 2 right here, 2 over 1, or just 2, whatever. I'm going to put a 2 there. If you remember what b is your y-intercept. And your y-intercept is when x is equal to 0, okay? And you're like, but Ms. Johnson, there's no 0 here. Okay, well, draw it in. If 0 was there, what number would this be? If 0 was here, it's catching up. If 0 was here, what would your y be? That's what it's asking to find your b, because whatever that number is, that number goes here. right? So I'm going to go backwards to find these numbers. So I'm going to go backwards here and fill in the blank here. So if I would add 2 to this number, it would give me 3. What number should I put here? What number should I put right here? Answer is 1. Johnson, how'd you get 1? Well, I was thinking what number plus 2 plus my 2 gives me my 3? What number plus 2 gives me 3? 1 plus 2 equals 3, Ms. Johnson. Very good. So I do the same thing again. What number plus 2? What number plus 2 would give me my 1? And you're like, oh, -1, right? So there's my equation. So this is -1. So my equation is 2x minus 1. So that is my rate of change, right? This guy here belongs here. Your rate of change, like the function of change. That's what it's asking for you. So I'm going to put in that equation here. So 2n minus 1. Hey, Ms. Johnson, I noticed that you changed from x to n. Why did you do that? I don't know, actually. For some reason, whenever I write y equals mx plus b, I always use m and x. For n, we tend to use it for tables because that's your input value. For functions, we use f of x or f of n. So that's one of the reasons. There's other reasons too, but for your purposes, this is good enough. Okay, the recursive rule. Again, Ms. Johnson, you want me to write the structure and then put my rate of change right there? Exactly. So I'm going to write my structure, which is just f of n equals to f of n minus 1 plus, and then I'm going to bring down my rate of change, which is 2n minus 1. Right, this guy here. Okay, so it's going to catch up to me right now. Okay. Oh, it's not catching up. All right, it's coming. But there's your answer. F of n equals f of n minus 1 plus 2n minus 1, right? This function here is this function here, which is this function here, which is this function here kind of thing. Sounds good, hun? Okay, so all of this, okay? And again, I'm going to do it again. I'm going to find this again, okay? So here I go. I'm going to find the same exact thing. So I subtract, that's 4, that's 10, that's 16, that's 25. Looks right. I'm like, ah, it's not the same. So let me go this way. So that's 6, and that's not 6, that's 9. Did I mess up somewhere? 1, 5, 14, 30, 55. So 4. Oh, I don't know how to add. That's not 9. Man, Miss Johnson. Woo. Miss Johnson makes some mistakes, guys. I don't know if you know that. Okay, so this is 9. I was adding too fast. 16, and then this is 25. Do you guys all notice these numbers? 4, 9, 16, 25. Oh, it's not catching up to me. Okay, so if you did see these numbers, you would recognize like, hey, Ms. Johnson, I recognize those. Those are all perfect squares. Oh, very good. So because this is quadratic, are you saying this must be cubic? This is what you're kind of guessing here. And if you did guess that, then you're right, because that's kind of right. But just to prove it, I'm going to move on to my next set. This is 5. This is 7. This is 9. And you're like, oh, Ms. Johnson, it's right. Look, these are both 2s here. Very good. So this is a quadratic function right here. This is quadratic. And remember, it lines up this way like this, right? So 2, 5, and then 4 in a row. Pretend those are all in a row. Oh, so does 2 squared give me 4? Yes. 3 squared gives me 9. 4 squared gives me 16. 5 squared gives me 25. Yes. So this one's relatively easy. It's just n squared. N squared. And then your function again is just going to be f of n equals f of n minus 1 equals to, oops, not equals to, plus n squared. Right? And there's your function. Okay. So like just to review really quick, whenever you're doing these types of problems, you're finding out the level of differences that it's at. If it's the first level of differences that are all the same, then it's called linear. If it's the second row of differences, then it's called quadratic. If it's the third set of differences, 1, 2, and 3, then it's called cubic. The rate of change is just that first row of differences as a function. So here, the first row was 1, 2, 3, 4, 5. Well, that's just the function n. And then this one was -5, -5. Well, that's just -5. This one was a little bit like, hey, where'd you come from? 3, 5, 7, 9. And you're like, oh, wait. I know how to do this. This is what I've been doing since like, I don't know, maybe 8th grade. Y equals mx plus b. Find your slope, plug in your y-intercept, and then you're done. Here's your slope right here, 2, because the difference here is 1. So rise over run, 2 over 1. That's my slope, that's 2. And then my y-intercept is none other than when x is equal to 0. So what's my y when x is equal to 0? You guys did this backwards, like go backwards to catch that. And this one was just, I recognize that this was perfect squares, 4, 9, 16, 25. And then I checked to make sure if I plug in 3, I should get out 9, which I did. All right. I hope that made sense. I know it did. Have a great day. Bye.